morning. I'd like to thank you all to being here today. Special thanks to all first guys who opened the door for us. We came from Brazil. We work at Ecolabora, a company that works with BPM software. And we are very proud to be here because our company sent us. We are enjoying the city. It's all fun. Well, we are not used to do this kind of thing, so I'm very anxious about it, so sorry about that. Well, my name is Silvio. I work as CTO at Colabora, but I started to work with software development when I was 15, so it's not allowed to work that early in Brazil, but we are not good at following rules, so I started very early. As you collaborate with a company about business process, I studied, and now I'm working more. I'm working in the middle of these two different worlds. Like I'm techie guy, but I know business. So in the middle, it's like like choosing the two worlds. Well, you know, business process is something that's old school stuff. It's not by now. When we say business process today, we're calling about something that was called the third wave. These guys, Howard Smith and Peter Finger, they see business process enabled by technology. It was 10 years ago, but we are not using it enough, in my opinion. We have a lot of solutions, cool solutions, but we're not solving problems, business problems often enough, because we are far from business. And so, to illustrate that, let me show Gartner. You know Gartner is a research company. They're huge and well-known, but you should. They say you should have a bimodal IT. So this mode 1 is about the traditional way of doing software, and the mode 2 is agile way. So take a look at it. They say we should have waterfall, we should have culture IT-centric, or conventional process and project. Well, I don't think we need both. We need to do always agile. But as Martin does just said us about the tools, they don't have tools to test software. It's the same for the methodology. We should use agility to do business process. So it's what Ecolabora do. We like to empower business people, but we have to give them tools to do this. Well, you should remember the fourth value of the Agile Manifesto. It says, responding to change over following a plan. It's okay for software. We should do this for business too. The business change, and when business people don't have a good tool to do this, they are stuck in their ERPs or something like that. Well, to give people the tools, we developed a software called Turbina. It means turbine in Portuguese, and it's because turbines are used to change a kind of energy in another one, like wind into electricity or something like that. And we want to change business people energy into better processes. So I told it all the story because we have made architectural decisions based on that flexibility you want. So it's all about makes sense for you what we're going to tell next. So our front end is all all web-based. We have a single page application based on Bootstrap, Jupyter Bootstrap, Backbone.js. We have HighCharge.js for graphs, a lot of frameworks. but you always use modeler, activity modeler, never active designer, because you don't want people to install software in the machines. They need to use a web-based solution. In the application layer, we have the activity engine, and the rules expire to be the business rule engine. And the integration of Titans, and it's a subject to another presentation, but everything that's not active stuff are stored in Titan graph database, like user, permissions, groups, inheritance, stuff like that. So the solution is important. Here, actually, we have a set of components, like the business process definition, business rule definitions, dashboard definitions, and the user form definition. That's important for our presentation today, because every field in a user form becomes a variable in the activity. So we don't model the data. We don't have like tables to every process. We use just the table of variables in activity. We end up with tons of variables, and we have some challenges to deal with this, and it's here where Elasticsearch enters the scene to deal with this. Mike and Diaz are going to tell you how we've done this.
Hi everyone, my name is Mike Diaz. I'm work at Colabora with Neta in São Paulo, Brazil. Silvio, actually. I have strong interest in big data and NoSQL projects, so I try to keep up with the things and the last news about it. So, and also the turbine fodder. So I am the responsible for the healthy growth. So that's a lot of responsibility. Also, I'm an activity committer too. I create some features and some bug fixes. Well, this is me. Now I'm going to talk about the big table problem. The big table problem is our main reason to looking for SQL alternatives. What is the big table problem? Who's familiar with the activity data model? Sure, everyone that shared. It's great. As you know, in the activity data model, the act high variance is the table responsible for store all the historic variables in the activity engine. And in the turbine way, for each field in the user form, you create a variable role in this table. And again, for each process and for each field, you have one more field in the 8i var inst. So this table will start to grow very fast. In one of our customers, we have a project that have 5 fields that in something around 1,000 processes per day. That's totalized 50,000 variables per day. So this is the snapshot of the production of the database. 15 million variables in 9 months. There's a lot of variables, but what is the big deal in this case? The big deal is online reporting. Sometimes it's hard to do online reporting and extract the data when you have a lot of variables and the SQL database needs to have joins and a lot of full table scans to retrieve the information. So this is the first, your motivation to look for SQL alternatives to do online reporting. With this problem in mind, we need to find the right tool for the right job. What is this tool? This tool is called Elasticsearch. Elasticsearch is the perfect tool for this job. Let's see why. Elasticsearch is built on top of Apache Lucene, that is a high-performance information retrieval library. This here is the place of the complex algorithms about search, and the computer science and things is built inside the Lucene. So therefore, Elasticsearch provides great analytics capabilities. That it means that Elasticsearch can ingest and retrieve data very fast. You can send tons of data to Elasticsearch and retrieve tons of data from Elasticsearch in a very fast rate of the transfer data and it. And furthermore, Elasticsearch is distributed. That means you can start small with just one node and scale as you grow, adding more nodes, and you don't need to do anything. The cluster can handle the additional nodes automatically, and you can take the advantage of the extra hardware. That's a pretty cool feature. Well, now you know about Elasticsearch. It's time to know how we index the data, activity data in Elasticsearch. Well, as we want to report and search about anything, we need to index the historic data to Elasticsearch. This is the first challenge. How we have done it? Imagine that this picture is all the process in the activity database. To be fun, let's call this amount of process as the process lake. It's a good name, I think. So, inside this process lake, we need to read the database and split this process in small batches, so we can get some parallel process. We split in small batches by core, so we can have more parallel processing, because your database can be too big and this can spend days and days. So splitting by CPU is a way to increase the performance. And after split inside the batch, for each process instance, we collect the variables related with the process instance and the tests related to the process instance, and then we parse to JSON and send to the REST API. This is the way, is how we send the historic data to Elasticsearch. And now I will drink a little water. Great. Perfect. Now we have all historic data indexed on the Elasticsearch. And now it's time to index the real-time data. Real-time is a buzzword that everyone likes. So it's a good to put in the slides. And how we have done the real-time, index the real-time things that happen in the activity. Anything that happens in the engine, the activity creates an event to register that this event happened. So everything, you know that everything is happening. And this is the key for the real time. Thanks for the event listings. All that we need to do is plug an event listener, filter the relevant events, parse it again to JSON, and send again to the REST API. Pretty simple, huh? I love it. So, it's time to play with the data. We already have the data inside the Elasticsearch. It's time to have a little bit of fun. And The first and obvious thing that you can do with Elasticsearch is search, right? And we can looking for something inside your process lake, and inside here we are looking for what's the process matches for some query or something like that. And this is the first thing that we did, and the first thing that it should be did. Here it's a pretty simple example of the Elasticsearch query. This query we are looking for what is the process that having the variables the text João Silvio. That's there. I found it. So there are many ways to do it. So this example is using the match query. It's a query that calculates the scores and find what is the best matches for the João Silvio. And when you have this feature, you can build interface like that. This is a print screen for the Turbina, the product that we created. And here we looking for João Silva and put the results in the what's the best results for for this word. These words are being searched. Thanks to Lucene, that can calculate and compute the search and best scores inside the amount of the process. We can have the best results and see this for us users. Now, as a polemic topic, is time to compare just two tools. The objective of this comparison is see how does these two tools performs to execute similar task. Think that it's similar for the two tools. What we will test is a pretty simple case that we will find what is the variables that the name is passport and the value is 1, 2, 3, 4. In the MySQL, we just do a little bit pretty simple SQL query. I select where the name is passport and the text is 1, 2, 3, 4. It's pretty simple, and everyone perhaps know how to do a SQL query. Pretty simple. And this is how we did with Elasticsearch. It's a little bit more complicated, but it's still easier. Here we, oops, sorry, that's the surprise. Here we use a special query called filter that is optimized query to find exactly values matches. That we don't need to calculate the scores that match the best best variables that match the score. We just need that. What is the exact value is 1, 2, 3, 4. And okay, it's time to run the test and see what happens. Elasticsearch is 2,000 times faster than MySQL. But wait. Why did this happen? Why? Because MySQL needs to perform a full scan over 15 million variables and looking for what's the variables match to the results. And here is the advantage to Elasticsearch. Elasticsearch, it's a know where is the information is, and this is when the Elasticsearch wins. But wait for the graph and forget about it. These tests are not a scientific comparison. I just pick the squares and run in the database environment. So I don't did any statistical methods and any neither the environment is equal. So you have a different parameters for SQL, MySQL, and you have a different parameters for Elasticsearch. This is a not fair comparison. I just put here to see what is the potential of the Elasticsearch. Actually, I don't did a scientific comparison because I don't have skill to do it because I know nothing about statistics, but that's okay. Well, what we have learned with using this activity extension. We learned that full text search is a helpful feature. When you put this feature in your product, we can realize that had a feature with a great value. The client uses it a lot. The client wants to find the process for some keywords, finds the process that match a specific keywords or passports or everything that they want. And the Elasticsearch can provide just an easy way to do it. It's an easy way to do this. And we learned too that we can reduce the MySQL workload. When we move some queries to Elasticsearch, what is the Elasticsearch do better? We can avoid the full table scans into MySQL. So MySQL can respond easier without worrying about the heavy joins and heavy joins and everything that is heavy to MySQL do. So it's great for us too. And Elasticsearch it's great for analytics. We don't cover this topic in this presentation, but we have tasted the power of Elasticsearch analytics and the aggregations in your product. So we are happy with the results, and this is a good subject for another talk about how do we use Elasticsearch analytics and activity. Well, what is the next steps for this extension? First, as the data is growing fast, split the process like by core is not enough. Perhaps you have a big database and you need more performance to start and index the stored data. So we have plans to use the Spark plans. I have plans to use the Spark Power to do this job. And also, in order to ensure that only the committed data is sent to Elasticsearch, we rely on the Java EE transactional system. And then this is the way that we can ensure that nothing more than the committed data is sent to Elasticsearch. We want to provide a way to customize it, and so you can use this extension in other platforms and other systems and something like that. And of course, we want to remove some specific Turbina classes and do a push, yeah, and make this extension an open source project that can be used by everyone, everywhere, and every time. And that's it. Thank you very much. If you have any questions about the subject, you can